This continues the lecture on section 2.2 on adding with unlike denominators or subtracting with unlike denominators. This is example 14, it's part C and D. So this next example, we still have unlike denominators here, and it's much like the problem where we had the denominators both being prime. However, in this case we have 4, which is not a prime number, but 4 doesn't have any common factors with 3, and therefore when we go to build the LCD, from 4's prime factorization, 4's prime factorization meaning 2 times 2, and then we put it together with the prime factorization of 3, which is simply 3, we see that we end up multiplying 4, which is 2 times 2 times 3. So this gives us 4 times 3, which is 12, and that's our new denominator. So we need to write in terms of twelfths, and then we'll be able to add. So next I need to build the higher term. 4 times what is equal to 12? 4 times 3. Well, you see here, this is 4, right? And so I see there's the 3. You can always use that as a little trick to get your higher terms built. And so we have 1 times 3, and 1 times 3 is equal to 3. Now 3 times what is equal to 12, so we want the 4 here, and then 4 in the numerator as well, so 2 times 4, which is equal to 8. And again, we add the numerators and carry along the common denominator, 3 plus 8, which is equal to 11, and the common denominator comes along for the ride of 12. 11's prime, it is not a factor of 12, therefore this doesn't reduce and we're all finished. Our next one is a case where one number is a multiple of another. When one number is a multiple of another, multiple means that if I multiply a number by the counting numbers, that I get its multiples. So 4 and 8 are related by multiples. So 8 is a multiple of 4. So the larger of multiples we have as being the LCD. And the way we can see this is see that 8 is 2 to the third power, and 4 is 2 to the second power. And remember, the way that we build an LCD is to find the unique factors, and 2 are the only factors that we see up there, right? 2 is the only unique factor, and then we're going to put it to the highest exponent. We have 3 versus 2, and the highest exponent is 3. So 2 cubed is our LCD. 2 cubed means, of course, 2 times 2 times 2, and that is going to give us 8. 2 times 2, which is equal to 4, and 4 times 2, which is equal to 8. So now that we know what the LCD is, then we're going to go ahead and we're going to build the higher terms, just like we have been in the previous examples. So 8 times what gives me 8? Well, this is just 1. In other words, we aren't doing anything to this one. We're just rewriting that fraction because it already has the denominator. And then 4 times what is equal to 8? Well, 4 times 2 is equal to 8. So 3 times 2 is what our numerator looks like, and 3 times 2, which is equal to 6. And then we add our numerators, and we carry along the common denominator. Well, this brings up another problem that our final answer here is an improper fraction. So remember, I want you to change those back to mixed numbers. The way we change it to a mixed number, we're going to take 11 and we're going to divide it by 8. 8 goes into 11 one time with 3 left over. So we have this being equal to 1, and 3 is our numerator over our original denominator 8. And that finishes our answer as a mixed number, which is where I want you to take it. So that's adding and subtracting with unlike denominators.